back to my channel. So in the last lecture, that is the lecture 1, force and its type, we have learned all about gravitational force, and today we are going to start electromagnetic force, which is really an important force. Electromagnetic force. So basically, what is an electromagnetic force? Electromagnetic force is a force that is developed or generated between two moving charges due to electric field and magnetic field. Fine. So what is it? This is a type of force which is generated between two charged particles. It can be this case also. It can be this case also. Or this case also. Alright. So electromagnetic force are generated between two moving charges, and charges, you know what I mean, and it is generated due to electric field and magnetic field. Fine, that's an important note to be noted. Now there are types of electromagnetic forces. Okay, there are types of electromagnetic forces. I'm going to use this abbreviation EM for electromagnet, so please note it down. Electromagnetic forces are of mainly 4 types. First of all, not types, but these are some examples. There are, a variety of electromagnetic forces, but what I'm going to mention are really important for the basis of NCERT for class 11th and also for NEET. Fine. So these all are examples which are mainly given in your books, etc. And actually questions come on these types of electromagnetic forces only. So what are the examples? These are only the important ones. First example is normal contact force, or we can say normal force. And second is friction, which is also really important one. Friction. And the third one is tension in string. And fourth one is spring force, the force generated by a spring. Okay, we will in this series actually we are going to learn all types of forces. Okay, and in that also, when we are going to learn electromagnetic force, we are going to learn each and every of these examples in detail, because these are actually really important according to the syllabus of NEET, etc., and also for 11th class, right? So it's actually really important, and this will make you basics for the other chapters which are going to come ahead. This thing will make your all concept really clear, and this is the foundation for it. Okay, so please hear everything which I say very clearly. So let's start from the normal force, right? But before that, let me introduce what actually how these forces are formed or something like that. Now let me take an example. This is the ground, and here I'm keeping a block. Obviously, everything in this world is made of atoms, so this block is also obviously made of atoms. Okay, and the ground is also made of atoms, and these atoms have moving charges inside them, right? We know that this is the basic knowledge. We know it has some moving charges moving electrons, moving protons. What I mean actually is that. And due to this moving charges and electromagnetic forces are many types of electromagnetic forces are generated. Now, one force which is generated is something like this. Okay, this is called normal force, N. I'm going to denote a normal force with an N in this whole lecture. And one force is this. Let me show. Which is with along the x-axis. This is F. What is F? Friction. Okay. And the third type of which we are going to start from is this one, FC, which is contact force, or we can say normal contact force, or simply normal contact force. Sorry, I before that when I was giving you examples, I told that normal contact force is also called normal force. No, normal contact force is normal contact force only, or contact force simply. Okay, normal force is this one actually. Now there is I don't know whether this question will arise in your mind or not, but let me tell you that why is contact force always inclined? Why is it not along the axis or y-axis like the normal and this friction force? Why is it like that? It is like that because uh, you know inclined forces are complex to solve. Therefore, we replace it by normal force and friction force, which are easier to solve. These two forces are easier to solve than this one. Okay. Uh, as we have replaced contact force with these two, both also are contact force. Do you understand what I mean? I mean that because contact force was inclined, okay, which is hard or complex to solve than these two forces, and because these two forces are the forces which are being replaced in place of this force, so these two forces are also contact forces. This is what I mean. Okay, normal force and friction force are contact forces. Okay, this is what I mean. Now let me introduce what normal contact force is. Right, normal contact force, let's understand. Normal contact force, it is an electromagnetic force. Okay, first of all let me tell you the definition for it. It is an electromagnetic force which acts perpendicular to the surface in contact. The contact should be tight, fine, which keeps object from passing through each other. Normal is developed when two bodies are kept in tight contact, and it is developed at the surface of contact. One contact develop only one normal force. It means number of normal forces equals number of different contact made by the body. This is something really important. Fine. For example, there is a block on a ground. Now the contact of the region of contact, the point of contact here is this. If you see it, right, this part. This is the contact. So normal is perpendicular, as we have written here. It is perpendicular to the surface. This is the surface. It should be perpendicular like this. This is the normal. This is the normal applied by the basically normal of the block. Right. Now let us take an actual example. For example, this is the earth. This is the earth. Okay, I can't make a perfect circle for that, sorry. Okay, so let us take a block on the earth. The normal applied by the earth on the block is this, perpendicular to it. There is the normal applied by the block on the earth also, but it is really small, so we neglect it often. Okay, for your convenience I'm going to write that also, mg. Okay, the value of that normal would be mg, and this also mg. Okay, this is how we calculate. Now magnitude of normal depends on the force applied on the surface. That is, the magnitude of the normal will depend on the force applied on the surface. Like example I have given here, this example only, this one, where the block applies force of mg. Mg force is applied by the block on the earth, and now earth also apply a normal equal to mg, like this. This is how you understand how normal force interact. Now magnitude. Now there is an important thing which I have to tell you right now about the magnitude of or value of normal. The magnitude of normal is self-adjusting. You have to remember it. That means its value changes according to the question or situation given to you. Okay, because yeah, normal would be self-adjusting. Remember that magnitude is of normal is self-adjusting. Self-adjusting. Self-adjusting normal magnitude. Now next topic is direction of normal force. Direction. Talking about the direction, how to find the direction, etc., we will learn here. Normal act we have already seen here. Let me show you. We have already seen here that normal is perpendicular to the surface. Fine. So again let's understand. Okay, normal act perpendicular to the surface. Always remember, normal acts perpendicular to the surface in contact. Perpendicular to surface in contact. Surface in contact. Alright, says that body on which normal acts tries to move away from the body which has applied normal. That means if the earth is applying normal on the block, so it will try to make the block move away from it. Okay, and same here, the block applies some normal on earth and it wants that the earth moves away from it, from the block. Okay, this is what we want, because if things would will not apply normal on each other, what will happen? The objects will sink. We don't want that, obviously. Do you want to sink when you walk? Obviously not, right? So that's why we are able to walk, because of normal. Actually, because of friction, we will be learning it in further lectures maybe, or yeah, let's see. Anyways, so let me give you some examples, and you should try to find the normal on it. Let me give you an inclined plane. This is an inclined plane making an angle of theta, and here is a block kept on this inclined plane. In numericals, in physics numericals, we often refer this inclined plane also as wedge, and sometimes also as prism. Quite weird, I know, but it's physics. And triangular block also, we often say triangular block, and which is the most appropriate is inclined plane. Okay, so here is a inclined plane where I have kept a block here. Find the normal on the block. This is your question. So let us apply the rules we have learned you know in the direction of normal, that it acts perpendicular to the surface in contact. Which, where is the surface in contact here? This is the surface in contact, so it will act perpendicular to it, right? On the block we have to find, so it would be perpendicular to like this. It would be like this, normal. All right, this is the thing. And this angle, this angle you're seeing would be equal to theta, this angle. Now why is it theta and how everything? This is something we need to prove, which is not in your syllabus, but if you still want it, please tell me in the comments. I will pin the proof in the comments only, because it's really easy. You just have to use Pythagoras theorem, something like that. Yeah, by extending this line here, you will take this angle as something and this as 90 degree, and then sum of these angles would be 180 degree, and like that you can find it out. Okay, but it is not in your syllabus, the proof why the angle this angle is equal to this one. So if you want the proof, you can tell me. I will make a small short video, or maybe I will pin the proof in the comment section or the description. Just tell me. Okay, now how to find normal when two surfaces are of surface of contact are not parallel? What does it mean? Let me tell you. For example, this is a wall and this is the ground or floor, and there is a rod leaning on the wall. Okay, it's quite wiggly, but my pardon. And this is the point of contact here, this is the point of contact here, and this is the point of contact here. Okay, yeah, we have marked the point of contact here. Now what do you think would be the direction of normal on the rod by the floor? First of all, the same rule, perpendicular to the surface, so this would be perpendicular to the surface like this. Yeah, but there is a trick to do this. First of all, keep your pointer or pen on this point of contact and see which of the object is on both sides of your pen or pointer. As you can see, the rod is not on the both side, but see, the rod is not on the both side, but the wall is on the both side. This is the pointer, and here also wall is there, but is the rod here? No, wall should be like this. Then only we could say, yeah, the wall is also on the both side, here also and here also, but it's not there. Only the wall is there here and here, both side of the pointer or point of contact, you can say. So you will mark it perpendicular to surface like this. Fine. Now what about the normal on the rod by wall? That is this one. How would we mark it? First of all, perpendicular to the surface, and the same rule will be applied here also, right? That is on both side wall is there, not the rod. Rod is not there, it's not extended like this. Okay, fine. So the normal again would be like this. Let me mark it like this. This is the normal 2, normal 1. Alright, now let me give you a tricky question. Sorry. What about if the rod is extending like this? Then what? This would be the same like this, normal. What about this? So let me tell you, it would be perpendicular to the surface still, but somewhat inclined. How? Because like this, because now the rod is on the both side of the point of contact. This is the point of contact, and the rod is on the both side, here also, but the this wall is not on the both side. Fine. So it would be perpendicular to the rod, perpendicular to the surface, right? Which is on the both side. Both side is rod is on the both sides, so it would be perpendicular to the rod, and perpendicular to the rod is this, not this. Okay, this is not the perpendicular of the rod. All right. So it would be like this. So whatever the normal would be perpendicular to that surface which is on the both side. Just remember this trick in your head. Okay, you can write it also somewhere if you want, but this video is always there for you. You can watch it anytime. Okay, now I am giving you two rules now to remember this thing, because I also, when I learned this topic, I also wrote these two rules so to remember. First rule is on the body where the normal is acting on, that will go away from the surface. That is, if normal is applying like this on the rod, normal is being applied on the rod, so the rod will move away from the floor. Okay, that's why it's not sinking in. There is some normal that is applied by the rod on the floor also, but we are not interested in it, because examiners don't ask question on that one. They ask only the normal on the rod or block or something like that. Okay, now what about the rule 2? Rule 2 is, just hear me out, okay, because what I focus on is making you understand the concept deeply, not just giving you some notes and PDFs to refer through it, that anyone can do, but explaining and understanding, that's what I'm trying to provide. Anyways, so rule 2 is normal normal will act in normal will act at 90 degree on the point of contact that is existing on the both sides, which I have already told you this thing, that whichever surface is acting on the both side of the point of contact, okay, that on the normal will act perpendicular to that surface which is existing on both side of the point of contact. Yeah, perfectly. You just write these lines directly, that the normal will act perpendicular to that, perpendicular basically at 90 degree to that surface which is on the both side of the point of contact. Okay, I hope you understand these two rules, which are quite important. Now now let me give you one more exceptional case which is quite important and you need to remember it actually. What if the rod is like this on the same height to the wall, like this? Wall is also ending here and rod also here. First of all, this normal would be same like this. What about normal on rod by the wall? It would be, you need to remember it, and let us apply both of the rules we have learned. Can we apply it? No, we cannot apply the rules which we learned in this thing, because as I already introduced this figure as exceptional case, we obviously cannot apply the rules we learned right now. Then what should we do? You need to remember this case. That's what we should do. It would be like this. This is the point of contact. One normal would appear here and one normal appear here. Let us take this as nx, which is along the x-axis, and this as ny, which is along y-axis. Fine. Familiar with it? Make yourself familiar with it, because this is an exceptional as well as important case to remember. Draw the diagram very thoroughly. Okay, now, so let me tell you, finally we have completed this topic, normal contact force, and that's it for today. In the next lecture we are going to start from friction, and if you want to, if you have any doubt, you can tell me in the comment section. Yeah, but never mind. Bye.